Hi, this is a quick video on a multimeter that I recently bought. I specifically bought this multimeter because I wanted a thermal camera and the ability to connect via Bluetooth to a mobile phone so I can transfer the capture data. There wasn't much choice. Flare-do thermal multimeter. It's quite expensive and doesn't have all those extra features, or none that I could see for that price range. This is a rebadged CEM DT-9889, which doesn't seem to be available anywhere. So this is from RS Components, and they call their version RS-9889. So this is what you get in the box. Manual. The multimeter is quite chunky. Got your thermal camera there. 2 batteries. I've already installed one. So these are 7.4 volt, 1.5 amp lithium-ion batteries. Came with a micro SD card, SanDisk Industrial 8 GB. This is for storing the capture images. A battery charger, power plug for the couple of country-specific adapters for the power plug, a K-type thermal probe, standard multimeter leads. I've seen them with some of the Chinese ones, so they are Cat 4 600 volts, Cat 3 1000 volts. The multimeter does measure up to 1000 volts. That's one of the other reasons why I got it. A magnetic clip at the back that goes on the back of the multimeter for mounting onto devices you're measuring, so you can trigger the measurement remotely. Could be working high voltages. A adapter for connecting different types of probes. And yep, that's it. So let's take the multimeter out. Separate connections for microamps, milliamps, current measurement, 10 amp, and your standard voltage, hertz, resistance, capacitance, diode, and continuity tester. It does have a setting for an external current clamp meter. So on the back we have the thermal camera, which is covered up using this slider here, LED light and a laser pointer, and underneath this stand we have the fuses and the battery and the SD card. So let me just open this up. There seems to be a seal around here. I don't know if it's IP rated or not. So here you have the lithium battery, and there's your SD card slot. Let's put this back on. Turn this 180 degrees to lock. Okay, so this multimeter is a standard 6000 count, same as all the other vendors like Fluke and so on. I can't measure the accuracy, but the accuracy based on the specifications sheet is what you'd expect. So the display is 2.8 inch TFT color LCD. It's got the built-in thermal imager with min-max center crosshair targeting, so we'll target the minimum maximum temperatures and display them on the screen. The refresh rate is 50 Hz, which I believe is quite high for a thermal imaging multimeter. Measures AC, DC, true RMS voltages and current, resistance and continuity test, diode test, capacitance, capacity, frequency, duty cycle, as well as the K-type temperature probe and optional current clamp. The field of view is 21 degrees and the IR resolution is 80 by 80 degrees. Accuracy is ±3%. So let's just have a quick look at the menu. So let's just put it on 10 amps. I'll put it on voltage. So you can change the color palette. So let's put it back. I think it's on this one. Might be useful if you're measuring different temperature ranges. So this has a temperature range, I believe, that goes up to, with the K-type probe, it's up to 1000 degrees, up to 600 degrees of resolution, 0.1 degrees, and the thermal measuring range is 260 degrees. Accuracy is plus minus 3%. So I'm not sure if other multimeters do it higher, but it's sufficient for my needs. So these are some of your settings that you can change in the recording. You can start recording and save it to the SD card. Okay, so go back to the menu. So if you go into setup, you need to turn the Bluetooth on. There is also a laser for targeting. Turn that off. You can adjust the brightness and the auto power off. So Bluetooth is always off, turns off whenever you turn the multimeter off, which is quite annoying. So I'm just going to go back to main menu. So the cool thing about this is, if I put it on voltage, so I could be measuring a circuit, and I can also turn the thermal camera on. It displays both data at the same time. So I'm just going to connect up a different set of multimeter probes. Okay, here I've connected up to a voltage regulator. So it's 6000 count up to 6 volts. So if I go down, it's auto ranging. So there's your 6000 count, goes up to 6 volts. Okay, so I'm going to turn on the thermal camera. So at the moment it's pointing onto my tube headphone amplifier there, so you can see the tube temperature is 64 degrees. So you can see I'm also taking a voltage measurement at the same time. I know it's not the same circuit, but you get the idea. So let's pair it up. The phone's got an old phone here. The application is FirmView Plus, available in the Android store or App Store. So the device is called, if I can find it, you can see all my smoke detectors. There it is, RS-9889 MR, and it shows where it was on the multimeter. Let's put this over here somewhere. I can hear the relay clicking, and it's for the thermal camera. I think when it detects a different temperature, different relay kicks in. So let's see how much of a delay there is. It's almost instant. So you get a little graph here. You can record a range. So I'm going to start recording. It will record a range over a period of time, which you can then view later, download from the SD card. You can also take a screenshot of whatever's on the phone. You can also turn on the thermal camera if it's not turned on, so you can do a remote turn on if you're not next to it, which is quite useful. You can also capture what's on the thermal camera, which is pretty cool. So you can go and click here and then view them. So let's take a closer look. So there's a capture I did. Shows you the high and low temperature. Lets you edit the file. So what do these do? So okay, so you can actually move the cursor around on a recording and read the different temperatures. That's pretty cool. And you can then save that. Cancel that. There's some screenshots that I took. So yeah, pretty cool. So if I go back to the thermal camera, captures whatever's on the screen. So that's a pretty cool app. It's one of the functions I wanted. So let's have a look at some of the thermal camera. So I'm going to point it at a different part So I'm going to point it onto the circuit board here, which is the charging circuit for the tube amplifier. This is battery operated. So as you can see, I can measure the temperature of the circuit, which is quite useful. So when I was initially designing this circuit, I didn't put enough heat sinking in, and it was getting about 80 degrees hot, which is too hot. So had I had this device, I would have known how hot it was getting when I was building my prototype. So I had to make quite a few revisions of this PCB till I get temperature. So I got it down to 51 degrees. Which is perfect, so this confirms it's correct. So I was using an external probe to measure, and I was getting roughly 50-55 degrees, so I believe this is giving a more accurate result. I also have another device here, an XC clock, that gets a bit warm because I'm converting 5 volts to 170 volts for the NXC, so some of the heat is transferred over onto the NXC, which isn't great. However, looking at it, it's 41, 42 degrees. I believe that'll be fine. And then if I open this up, there is a power supply module there, and the hottest point there is 60 degrees. So maybe I can do something about that, redesign the PCB. It shouldn't be getting that hot, so it's not a good sign. So this is quite useful to confirm. So I was using my finger really to measure these temperatures and finding the PCB is too hot. So this device really helps in identifying the exact temperature, and that's really too hot for a clock that's going to be on all the time. And the heat's being transferred over to the NXCs, which isn't great. Okay, I've got some resistors, capacitors and a diode just to do some basic testing. I don't have a like a fluke multimeter or another expensive multimeter tester. All my multimeters have been cheap in the past, so I decided to upgrade to something better. So this was a good choice for me. So I'm going to turn the infrared camera off, switch, let's disconnect this. Switch over to, so it's on resistance at the moment. So this is a 10k 5% power resistor. Yeah, that works. So let's press the mode button. Let's continue to, let's put it on diode. So this is UF 4007. Voltage drop of 4.8 volt at that voltage, which is about right. And then capacitors. So positive terminals. This is a 450 volt 100 microfarad capacitor. You can still see on the mobile. Okay, so yeah, so the accuracy or the tolerance of this Rubicon capacitor is plus minus 20%. So this is kind of what I expect. I did use another multimeter to verify that, so the readings are the same. Okay, and this is 47 microfarads. Yep, so looks all good.